Hi, what we're going to do tonight is we're going to talk about the point slope form of a line. As we all know, there are, or may not know, there are three forms of a line that are critical that you understand when you're doing algebra. The standard form of a line, the point slope, and the most common form of the line, the slope-intercept form of the line. But we're going to focus on the point slope form, why it's useful, how to find given 2 points, how we find an equation that contains both of those points, and we're also going to do a few other word problems. So let's get started. All right. So the three forms of a line that we need to know by the time that we complete. Algebra are the slope-intercept form of the line, the point slope, and the standard form. Now the slope-intercept form of the line and the point slope forms are defined really by the information given in each form. So for example, if you look at the slope-intercept form, that is y equals mx plus b. And what you get what you're given in this form is you're given the slope and you're given the y-intercept. So that's your slope is m. Why it's m, I don't know. And yb is the y-intercept, I don't know either. Why they use those exact letters, not sure. Maybe someone can do some research and let me know in the show notes. Okay, so if I know that the slope of a line is 2 and the y-intercept is minus 4, then I can write the equation of the line by simply plugging in my m and my b like this. So I would say y equals 2x minus 4. Why minus 4? Because it's the y-intercept is negative 4, and that's my form of the line. So this is something I assume that you know. I am assuming you know this. If not, let me know and I can do another video on the slope-intercept form of a line. But the key thing we're going to be looking at is this point slope. Let me quickly hit on this thing called the standard form of the line, and that's a line that looks like, whoops, this should be a, oops, oh my goodness. Let's just fix this right now because this isn't right. This should be a y. So y. So the standard form of a line is ax plus by equals c. And we're not going to talk much about this form of the line at all tonight. But it would be if you see an equation that looks like this, 4x plus 5y equals 10, you can know that this is the equation of a line. This is the equation of a line, but we are not going to talk about it, why it's useful, or why mathematicians write lines in this form. It is useful, and I can explain that in another video, but not tonight. So we're going to focus right now on the point slope form of a line. And why do we call it the point slope form? Well, it's because you, instead of given the slope and an intercept, you are given a point and a slope. So, for example, instead of given m equals 2 and y-intercept is negative 4, if you were given a point 3, 5 is on the line, and the slope is 4, then I can write an equation just given this information without really doing any math. I can just plug in my points and my point and my slope and get the equation of the line. So let's just identify these key parts, right? If this is my slope, this is m. And if this is my point, this is my x1, and this is my y1, right? Because points are all written x comma y. So I can just take these numbers and plug them into this formula and say, well, the equation of my line is y minus y1, which is 5, equals my slope, 4, times x minus my x1, which is 3. And so if you were to be given this problem here and that the teacher says, well, I want you to write an equation of a line, you could just write this equation right here and be done. Okay? Now, if they say they want this in slope-intercept form and they give you this information, 3, 5 and slope of 4, then you're going to have to convert into that form. And I imagine you might know how to do that, but we'll do a problem like that later on in this lesson. So let's cut over to some examples. Okay, so this problem was given to me by my niece Gigi, and my niece? Yeah, my niece. And she asked for some help on some homework, and that's kind of what the genesis of this video is. So if you like these videos, feel free to ask for more videos. I love doing math videos. But let's get right to business here. That's what you came for. How do we do these types of problems? So we just practically did this problem on the other page. So if we need to write the equation of a line with slope of 3 passes through the point 2, 4. Now notice. They ask it in point. They want it in point slope form. They want it in point slope form. So let's remember our equation. Y minus y1 equals m times x minus x1. Now all we have to do is identify these pieces of information. x1, y1, and m. Well, that's easy enough. We have a slope of 3, so that's our m. Here's our x1. And there's our y1, so let's just go ahead and do it. Y minus 4 equals 3 times x minus 2. Right? I always like to box my answers. That tells the teacher that you are committing. I am committing to this answer. They don't have to look around on your page for what you think they think might be your answer. It's a solid commitment. And that's easy. That's easy enough. We don't have to go about converting this thing into y equals mx plus b form, slope-intercept form. We're done. We read the problem, did really what I call no math, and just wrote the answer. So let's get into some problems now where you have to do a little bit of math before you get to the final answer. All right. We have something a little bit different. We have 2 points. So now if you're given 2 points, there is no way to get straight to the answer. You have to go through 2 steps. Given 2 points, you need to use 2 steps to get to the form, not form, we'll call it the equation of a line. Step 1, find the slope. Now, notice if we find the slope, then we have m. And once we have m and we have a point, we can write the equation of the line. Now write the equation of the line in point-slope form. Equation of line, whoops. My writing is a little bit messy on this tablet. In point-slope form. And now kind of point number 3, I'm going to put it in brackets. If necessary, convert. You know what? I'm going to pause for a second and fix my pen. All right, hopefully it's a little better now. If necessary, convert to slope. Yeah, I think it's working better now. Yeah, I don't look like I'm an old person writing. So if necessary, convert to slope-intercept form. But we're not going to do that here. We're going to do that in a later problem. Okay, so what are we going to do? Let's find our slope. And remember, our slope is equal to y2 minus y1 over x2 minus x1. Now we're going to call this point, x1, y1. And we'll call this one here x2, y2. I like to label it sometimes because so I don't get too confused. All right. All right. So y2 is 5 minus y1, which is negative 3. And we know what subtracting a negative is. We'll do that in a sec. Over x2, which is 4 minus x1, which is 1. Right? So we can subtract our negative by adding a positive. So that's 8 over 3. Good? Now we can write the equation of the line in point-slope form. Now, a lot of students will ask the question, well, they'll ask, which point do I use? I want you to think about that a second. And the answer is either point. And let's just do that. It can be either point. So let's do, we'll use both points just for fun. So remember, the equation of our line is, y minus y1 equals m times x minus x1. But it could be y2 minus x2. We could use either point. Okay, so we're going to say, well, y minus negative 3 equals 8/3, which is our slope, times x minus 1. And so we need to simplify this and say, well, that's y plus 3 equals 8/3 x minus 1. And that's one answer, but you could have easily answered y minus 5 using our other point. We could have said, well, it's minus 5 equals 8/3 x minus 4. And these are the same line. That's one of the interesting things about point-slope form. Point-slope form, there are lots of different versions of the same line. That's one reason that mathematicians prefer the slope-intercept form, because there's only one form of a line in slope-intercept, but there's many for point-slope. So if I were to convert these 2 points into slope-intercept form, you'd actually get the same answer. We're going to do that later, but not on this slide. Okay, this is the same problem that we had before. Same one as we did on slide 3. So if you figure, if this is easy for you, maybe go ahead and pause the video, try this problem on your own, and then if you get the right, and then just if you think you have the right answer, just fast forward through all the work I'm doing, and then see if you got the right answer. And if you got the right answer, great. Then just go to slide 5. But if you got it wrong, watch me do the work, and then you can see where you got the answer wrong. All right, so pause and try regardless, and then come back and see me do the work. All right, I want you all to pause the video and try this one. All right, I assume you've tried it, and so now let's look. We have slope equals y2 minus y1. I'm not going to write it all out anymore, all the formulas. I'm just going to say y2 minus y1 over x2 minus x1. And I'm going to get 2 over 4, and we can't leave it like that because it can be simplified to a half. So our slope is a half. Now we can use either point, remember, either point to write our answer. So I'll use the first point here. Y minus 3 equals 1/2 of x minus 2. That's version 1, but that's not the only answer. You could have also just as easily answered y minus 5 equals 1/2 of x minus 6. Now I want to show you how either one of these point slope equations, if we convert this into y equals mx plus b, or slope intercept form, you get the same answer. So let's just do that math here. So if we do slope intercept, remember we have to have y by itself on one side. So what we're going to do first is we're just going to get rid of this half, and I'm going to do it just by distribution. Sorry, not getting rid of the half. I'm going to distribute to get rid of the parentheses, and now I'm going to add 3 to both sides, and I get y equals 1/2 x plus 2. So this is, again, slope intercept form. And notice we still have the same slope because we have to have the same slope. If it's slope intercept or slope or point slope form, the line's always got the slope of a half. But now we have identified the y-intercept, which is 2. So let's see if we get the same answer. We better get the same answer, but let's just go ahead. Y minus 5 equals 1/2 x minus 3. Add 5 to both sides. Y equals 1/2 x plus 2. Oh my goodness. Oh my goodness. We get the exact same answer. And you know what I used to do is I used to do this thing. Oh my goodness. Where is it? I got to find it. It's Happy Cat. Where is Happy Cat? Have they taken away my Happy Cat? Oh my goodness. We could do Happy Cow. Oh my goodness. All right. We're going to call this Happy Cat. This is Happy Cat, looking a little different than used to on some. If you've seen some of my other videos, Happy Cat has changed his look. But this is Happy Cat. And we're going to put him down just because when math does really cool things, I like to just pop down a Happy Cat because I love math. All right. We're going to keep going and work on some word problems. All right, we have this word problem out of a book. Word problems. Man, those can be tough sometimes, but let's see if we can make some sense out of this one. Hey, let's use green. All right, so the ordered pair, when they talk about ordered pairs, we're talking about x's and y's, right? Ordered pair, points, same difference. So when we talk about, we have 2 ordered pairs, and we talk about a slope that's constant, a slope that is constant. A constant slope means a line. Means a line. And when you talk about a line, that means that it can be written as a linear. Any line can be written as a linear equation. Okay, so those are the key words that you need to be looking at in your head. And when you see that, you know that we have a line. And when we have a line, we then look for 2 points. And hey, we are given 2 points. 1, 5, and 2, 8. So we have everything that we need to write an equation. So let's go ahead and write an equation of this line. And then let's see, then we'll go about answering the second part of the question, which is how many seashells, how much money should she sell 5 seashells for? So let's just kind of write this down. So we have these X and Y points. I'm going to draw a little T-chart like this. So we know that one shell sells for $5. These are dollars, and these are shells. And we know that 2 sells for 8. And the question kind of is, how many sell for 5? Or how much money do we sell 5 shells for? So let's go ahead and write the equation of the line. And once we write the equation of the line, we can answer this question. We would know how much she should sell 7 seashells for, 10 seashells, 100 seashells. That's the power of a linear equation. But let's just do the basic math that we've been doing to figure out the equation of this line. If this here is our, this is our first point and our second point. So what did we do? What have we been doing if we're given 2 points? Remember, we need to find our slope. That's the first step. If any of you get confused, right, you can always just go back in the video, look back to I think it was slide 2 where I really wrote out all of these formulas. So I'll go ahead and write it out again. So the first step is finding the slope of this line. So we're going to call this point 2 and this point 1. So y2 is 8 minus y1 is 5 over 2 minus 1 equals 3 over 1. So that is our slope, 3 over 1. Now we can use either equation here to find our point slope form. So let's do that. We're going to just use the easier one. I'm going to use the one with smaller numbers. Why? Because the math is easier. So y minus 5 equals 3 times x minus 1. Well, let's go ahead now and put this, let's put this in point or in slope intercept form. So this is point slope form. But I want this in slope intercept form. And the reason is because it makes it way easier to find a y given an x. Here, if I say, well, if I put this 5 in for x, I'm going to have to solve for y. But watch what happens when we put this thing in slope intercept form. How easy these questions become. So y minus 5 is 3x minus 3. I'm going to add 5 to both sides. And my final equation now in slope intercept form is y equals 3x plus 2. And this tells me for every x value, I can easily find a y value, right? If I have one shell, I put a 1 in here, and I get 3 times 1 plus 2 equals 5. If I have a 2 in here, I can say 3 times 2 plus 2 equals 8. Now, to easily find what I need for 5, how much I need to charge for 5, I just put a 5 in for x, and then I can get out my y. So I'd say 3 times 5 plus 2 is 17. So my answer, 5 shells should cost $17. Now I'm going to give you a bonus question. How much would 100 shells cost? I want you to pause the video and tell me how many dollars 100 shells cost. So I'm waiting for you to pause. All right. Now I'm going to assume you came back. And for those of you who said, hey, Mr. Lipscomb, the answer is simply you just put 100 in for x, and then we'll figure out what our y is. 3 times 100 plus 2 is $302. Now that's some real moolah. $302. Let me ask you another advanced question. If I brought $500, now let's say I had $62. How many shells could I buy for $62? All right, pause, think about it, and come back. We'll answer the question in blue. Okay, I'm assuming you tried it. Maybe some of you got the answer, but the way that you figure it out is you just put we now know y and we're looking for x. So we'll take our linear equation, we'll put 62 in for y, and then we'll solve for x to see how many shells we could buy. All right, well, let's subtract 2 from both sides. 60 equals 3x. Well, x equals 20. So we could buy 20 shells for $62. All right, well, that's enough of that. We're going to now go on to the final question. All right, so maybe this looks like a tricky problem, but let me give you a hint. Usually when you see a T-chart like this, you are going to call this X and this Y. Okay, let's look at this problem. The following chart shows the wear on a brand of tires every 10,000 miles. What is the average rate of wear for this brand of tires? Now, let me tell you that this is usually a problem where, you know, if we're doing linear algebra, this is probably going to look like a linear problem, a linear algebra problem. So this could probably be modeled with a line. And we'll just verify that. So here's what we're going to do. I'm just going to make a quick and dirty chart here, and then we're going to verify that this looks like a line. All right. We're going to call this X and Y. So X, this is our X-axis. This is our Y-axis. And this is going to be our mileage. And we're going to do it in thousands of miles. Okay, so we're going to call this 10. Okay, we're going to start at 0, 1, 2, 3, 4. Every 4, we'll call it 10,000 miles. 1, 2, 3, 4. That's 20,000. 1, 2, 3, 4. That's 30,000. 1, 2, 3, 4. 40,000. You can fast forward if you don't want to watch me make a graph. All right, and then we're going to go, and we'll go every 2 will be, every 1 will be 2. So that's 2, 4, 6, 8, 10, 12, 16, and 20. Now remember, these gaps all, when you're making your graphs, these all have to be the same amount. You can't make them different amounts. All right, so at 10,000 we have 20. And right, let's label, this is our tread depth. Tread depth in millimeters. All right, always label your graphs. So there's 10, let's do a different color. Okay, 20, 16, 20,000, 16, 30,000, 12, and 40,000, 8. So indeed, you can indeed see that this is indeed a line, right? That is a line. So we have a linear equation. So what are we going to do to find the equation of the line? Well, we have 4 points. We have 4 points. Which ones are we going to use? And the answer is any 2. Let's take the easiest ones, the ones with the smallest numbers. I'm going to take this one and I'm going to take this one. We'll call that x1, y1 and x2, y2. All right. And we're going to write our linear equation. All right. y2 minus y1 over x2 minus x1. That's our m. So we get 16 minus 20 over 20,000 minus 10,000. All right, so we get minus 4 over net over 10,000. All right, and to simplify that, 10,000 is divisible by 4, so we get negative 1 over 2,500. So that's our slope. That's our slope. And notice the units of slope. The unit, and I'm going to give you a little bonus here. I wasn't going to get into this, but the units of slope is always, just like you do your y's over your x's when you're finding your slope, the units of your slope is the y-axis, label, over your x-axis, label. So in this case, it's millimeters per mile. Right? If this was, and that would be if this was like 10,000, 20,000, 30,000, and 40,000. So the answer is the units are millimeters per mile. So we lose 1 millimeter of tread every 25,000 miles. And wait, that's the answer to the question. What is the average rate of wear for this brand of tire? It is that's our answer. We're done. We don't even have to write the equation of this line because we've answered the question. Every 1 millimeter, every 2,500 miles, we lose a millimeter. We are done. I am definitely going to happy cat this one because we're done. That's just cool math. Now, if you wanted to go about writing the equation of this line, what will we do? We just pick a point, pick the easiest one, and just write it out. Y minus 20 equals negative 1 over 2,500 x minus 10,000. And if we wanted to write that in slope-intercept form, we could do that. Y minus 20 equals negative 1 over 2,500 x, negative times a positive, plus four. And then y equals, we're going to add 20 to both sides, equals negative 1 over 2,500 x plus 24. Which is an interesting, now this is even interesting, right? Because what does it tell you? It tells me a brand new set of tires, when x is 0, this disappears, and y will equal, when x equals 0, y equals 24. What does that tell you? It tells you a brand new, let's just keep that line going, a brand new set of tires has 24 millimeters of tread. Very cool. We can also go about figuring out, if we wanted to, when the tread is completely gone. And I'll let you figure that out on your own. All right, so that's it. We did a lot of work here. We did 35 minutes worth of work. Hopefully, if some of the stuff was easier for you, you just fast forwarded. If there's any questions you have, please leave me a comment and I can try to answer that or do another video. But I love doing this. I love doing math, so don't hesitate to ask for any more help in the future. Happy cat, and good night to you.